What is Shor's algorithm and how does it threaten Bitcoin? Shor's algorithm is a quantum computing method that efficiently factors large numbers into their prime components. This ability to factor large numbers into their prime components makes it theoretically possible for a quantum computer to break cryptographic algorithms like RSA and elliptic-curve cryptography, which are used to secure the Bitcoin network. In other words, Shor's algorithm could be used to break the encryption that secures Bitcoin transactions. The Q-Day Prize, a global competition to beat the clock Project 11, a quantum computing research and advocacy firm, has launched the Q-Day Prize, a global competition offering 1 Bitcoin, BTC, to the first team able to break an elliptic-curve cryptographic, ECC, key, the cryptography which secures the Bitcoin network, using Shor's algorithm on a quantum computer. The contest is a high-stakes game of cat and mouse, where teams must use their skills and expertise to crack the encryption before a potentially rival team does. Why is Shor's algorithm a threat to Bitcoin? The threat posed by Shor's algorithm is not just theoretical. With advancements in quantum computing, it's possible that a workable quantum computer might only be a few years away. This raises concerns about the long-term security of Bitcoin's cryptographic systems. In fact, Project 11 has identified more than 10 million Bitcoin addresses with non-zero balances potentially at risk of quantum attacks. What is a quantum-resistant address migration protocol, CRAMP? The Bitcoin community is aware of the quantum computing threat and is working on solutions. One proposed solution is the Bitcoin Improvement Proposal, BIP, titled Quantum Resistant Address Migration Protocol, CRAMP. This BIP suggests enforcing a network-wide migration to post-quantum cryptography to safeguard Bitcoin wallets. However, this would require a hard fork, which is a significant challenge. Alternative solutions, coarse-grained boson sampling, CGBS. Another proposed solution is a quantum-based alternative to Bitcoin's proof-of-work called coarse-grained boson sampling, CGBS. This alternative, proposed by BTQ, works by using quantum computing to generate unique patterns of photons, light particles called bosons, replacing traditional mining puzzles with quantum-based sampling tasks for validation. However, like CRAMP, CGBS also requires a hard fork, and the appetite for such a change isn't yet known. Breaking the code, challenges and opportunities. The challenges of implementing these solutions are significant. However, the potential benefits of safeguarding Bitcoin's cryptographic systems cannot be overstated. As the Bitcoin community continues to explore these solutions, the debate around the future of the network will only continue to evolve. Conclusion: the threat posed by Shor's algorithm to Bitcoin's cryptographic systems is a pressing concern. The Q-Day Prize and other initiatives like CRAMP and CGBS offer new avenues for innovation and progress. As the community continues to explore these solutions, it will be crucial to weigh the challenges and benefits of each approach. The future of Bitcoin security will depend on the collective efforts of its developers and users to stay ahead of the curve.